Well, good evening and welcome to this evening's webinar, Mathematical Methods Implementation, Term 1, hosted by Texas Instruments, Australia. My name is Rodney Anderson. I will be your host for the webinar. This webinar is being recorded and will be available to view at a later date via on-demand, along with the panelist documents. It is recommended that you view the webinar and not try to the activities as you watch live, as you can pause, fast forward, and rewind and record the webinar at a later date. If you want to actually ask a question during the webinar, move your cursor to the top of the screen and down will drop a box. Please select questions and chat and send it to me, the host, Rodney Anderson, and we'll endeavour to answer all of your questions during the webinar. Now, after the webinar, your feedback is important to Texas Instruments Australia, and this helps to improve the webinar series, the presentations, and change the webinar format. So it's a short number of questions, and please answer the questions. Also, within 2 days, you'll get an email with the links to resources and the important link to print off your certificate for your professional development records. Our two presenters for the night are Frank Moyer, as you see there, is a very experienced gentleman, and as Frank is using rich tasks and investigative approaches to mathematics, so it's very important that he uses that. And our first presenter for the night is Bozenna Graham, and as you see there, she's been teaching VCE and IB mathematics at Wesley College for 14 years, and she's a person that presents at state conferences and T-Cubes International, so I'd like to Bozenna and welcome her and Frank to the webinar tonight. I'll ask Bozenna to start with her section of the night.
We're just getting my screen ready. So I will start today's webinar for Mathematical Methods Unit 1, and Frank will concentrate more for Mathematical Methods Unit 3. I will start with two activities. The first one will be on coordinate geometry, and the second will be modeling with power functions. Then Frank will talk about bisection method and drag dosages. I will look then at inverse function and polynomial graphs with repeated roots, and Frank will look at a sample application task. So the activity I have chosen to start with tonight is actually the activity which is designed by VCE, and you can find this activity in Advice for Teachers, and it is on line segment graphs and review of coordinate geometry. The first 5 parts are meant to be done without calculator and then check everything on the calculator, but of course that can be managed in class differently as well. So what I have done, as you can see, creating some points and connecting the lines. I will just do a few for you in a second, but show what we can do. This is the notes page where we can find the distance between 2 points, so you can, of course, change the numbers and then the distance will change. The reason it's not exact, I have another activity here, is that I had to have it approximate in this particular thing. So that's a nice activity students can do themselves, and they can have that saved and be able to find actually the distance between 2 points. Sorry, I got the wrong thing. So next thing we can create using geometry perpendicular and parallel lines, and in regression line we get the regression lines and also the piecewise function to connect all the segments, and we can create the file with looking at the gradients and positive and negative gradients, which also can be done looking at the angle of inclination. So what I've done here, I have positive gradient, which is actually not a positive gradient, so if I assign the value 2, then I get a positive gradient, and here we can assign a value, let's say -1, and that gives students the gradient. So it is a good activity as well to practice on. So the question is, how do we do those things? So if we get the first graph screen, to get the points on the line, we are using geometry, and we're selecting points and lines, and at this stage we just want a point. We can put the point anywhere and then escape, and we need the coordinates of this point, so we go menu actions, coordinates, and this is just any point. But if we want to have a particular point, so we double click and say let this point be 2, and then let this value be 4. So that's the easiest way to enter a point. Then I want the line segment, so I go menu, geometry, and points and lines again, and segment. So I want the intersection 0, 0 connect to this particular point. So you see this screen on the corner, so I'm still in the segment thing, so escape. So now I can do geometry, and I can do construction, and I can construct the midpoint on this line segment, and then I can also get the coordinates of this midpoint doing the same thing like that. So that's the midpoint clearly having the coordinates. So I can also measure the angle, geometry measurement, and I can measure the angle of inclination, so starting at this point, going here and picking any point on, and because I'm in degrees, I can see the angle. And then we can construct the other lines joining and the whole thing as prescribed in this particular activity. If we wish to get the equation of this particular line segment, we need to actually draw a line. So instead of having a line segment, we need to go points and line, and I want the line through this point and through this point. And you can drag the line and extend it. And then if we go to menu, actions, and coordinates and equations, we get the equation of this straight line. If we want to make another construction, we want to draw a parallel line. Again, it will only draw the lines when we have geometry and line segments. So let's say I will hide this, and I will create another point, and I will try to draw the lines which are, so I just want a point. Let's get a point anywhere there. It doesn't really matter. And now if I want to create the perpendicular line, I need to go to construction and perpendicular, and that's the point, and that's the segment. And the perpendicular line is created. And again, we can go to actions, and we can get the equation of this line. And of course, it will be perpendicular to 2x, so they can see the connection. So this is just a few hints how those constructions can be made. And I just need to get back to my screen. So that's how we can actually get all those points and midpoints as I did, going one by one. You can change color, you can play with this. The next thing they are asked to do, so that's part of the construction, they are actually asked to get the equation of each line, so doing it by hand, but then taking any points. A pair of points then can do linear regression, so get the equations. And once they have the equation of each line doing the linear regression, they can enter this as a function up to here, not as the vertical line. So using the piecewise function, the piecewise function is here. And we here needed 4 pieces, so you could change that as 4, and then you can create a piecewise function. It's a bit long to enter everything. So I've entered. That's a good discussion when 5 cannot be actually appearing twice. so because it wouldn't be a function. So entering the piecewise function draws this graph up to here, and actually they say to hide the equation. Hide the equation. Now, how to enter the vertical line? The vertical line is a trick here. So what we do, we actually go to menu and actions, and we put a text. So you can put text anywhere, and we want x to be, let's say, 17 here, and 17 given that y is between 0 and 2. So we restrict the y values is less than y and is less than 2. Now I need to escape from, didn't work. So what you do next is if you escape graph, you just drag it on the line and it draws the particular graph. So that's the trick, to draw the vertical line in between two values. For y, it only works in operating system 4.0, so if the kids are saying it's not working, they are on the low operating system, and that is actually quite good to discover that it had happened. So now the next thing they are asking is to find the area between this particular piecewise function and the vertical line and the x-axis. They can do it using, of course, simple triangles, but there is a feature which is bounded area. So that's a graph as it was, so and the x-axis, and then we go from this point to this point. And I have done it before, but then we get the area. So important thing is that it is the piecewise function, so we have that as one graph between 2 points, because if you do single pieces, you would be able only to get single areas. So that's just a few tricks how that would work. So here I have the construction, as I said, for the gradient with the slider, and I put positive and negative so they can see that the actually gradient inverse 10 gives minus 45 degrees, but because the angle of inclination is defined as the angle between positive and the line, then we are required to give this line, this angle, and that also is shown in these notes pages where, why is it changing it? Because that's the gradient which I had on the screen. Okay, so that's what those two pages are actually connected, so I need to have it, let's say 3, and because it is the same problem, and then we see the angle. So that's just a few ideas how we can create this particular activity. And the second one is the modeling activity, which starts with getting this particular handout to the students. It has 2 pages. It has this page, and then it has some ruler, but they don't have to use this ruler. They can use a regular ruler. So the idea about paragraphs here is that they get in pairs and they try to measure the width and length of each paragraph, and they will try to find a model to fit the data. So it's good to have the initial class discussion, and how does the height depend on its width, and what values can width take, what values can height take, and depending on the students, of course, they only earn in methods. There are some quite interesting discussions happening. We have covered power function hyperbolas. They don't see it straight away, but after some discussion, it's quite interesting. So we ask them to predict, and even if you don't know, what do you know for sure? So this activity would fall within sample context features of graphs of functions from data. So they in pairs, they measure each paragraph and they enter the data in the spreadsheet. And at this point, it's again interesting discussion asking them, so what sort of function would you try to find in regression? They start with exponential, they try a few ones, finally they actually arrive at power regression. and they can get this value. Then, of course, we can get the graph. I might get another graph here. So we say that we want the width on the horizontal axis, width, and then if we click here, we want the height. So this is clearly a hyperbolic graph, and if we wish to get the regression line, they go and show power. So that's the equation, and then it's an interesting discussion, what does this number 16.3 stand for, and this is a really nice activity, and they quite enjoy this activity. So these are the two ones which I was starting with, and now back to Frank for the bisection method. Thank you.
Thank you, Bozenna. Yes, personally myself, I'm teaching the units here in Queensland, and it might be a good activity to try with my students. So with your section coming up, Frank, what are you actually going to show as we're waiting for your screen?
Okay, so I'm going to be talking about the bisection method first of all. So the bisection method is new content for Unit 1. Bisectioning Unit 1 is a numerical method, and Newton's method in Unit 2 as the numerical method that's required. So what is bisection? Bisection is a numerical iterative process which allows you to find the root of a function by systematically halving the interval which is known to contain the root. So I think that the inclusion of this material in the new study design perhaps indicates an emphasis not just on getting answers, but also getting students to think about possible solution methods, and in particular for students to realise that solving an equation does not necessarily mean factorising, that there are other methods, and in fact in engineering most of the time numerical methods have to be used.
So we've got it on your screen now, Frank. We've got your PowerPoint ready to go, so you're good to go, mate. Okay,
so I think that PowerPoint seems to be slow, so I might just jump straight to, given that the internet is so slow, I might jump straight to the TI-Nspire document. So in TI-Nspire, it's an excellent way of showing how bisection works. So I know that the root of this function is somewhere between A and B. And how do I know it's between A and B? Because f of A and f of B have different signs, have opposite signs. Obviously, one has to be...
Sorry, Frank. Sorry to interrupt, mate. Just we haven't got your Nspire screen on at the moment. So
all right.
So you can see, as Frank's just about to chat, if you see the third PowerPoint slide, that's your first slide on the Nspire, isn't it, Frank, with what you're about to show shortly?
It's 1.2 I'm showing. Mm-hmm. Okay, so I think I might have to forget about the PowerPoint.
Mm-hmm. But yeah, just as what I'm seeing your PowerPoint slides, so it's still progressing to your Nspire software.
Okay. I might actually close PowerPoint altogether, forget about that, because I think our internet connection's just too slow for it to work.
That's okay.
Okay. Perhaps if I've got fewer things open, it might be a bit faster.
Quite possibly, yes. Yeah, and after doing that, what are you doing after that, Frank?
After bisection, I'm going to be looking at some bits of application tasks which are in the advice for teachers. So I don't know whether teachers realise that the VCEE is providing supplementary material to the study design, and it's called Advice for Teachers. To find it, the best way is just to Google VCEE Advice for Teachers, and it'll come up. It comes up in a site, in a Victorian government site called DigiPubs, and I gather that the pubs is for publicity, not for places that sell alcohol.
Yes.
But so you can either go through DigiPubs or just Google it. I think it's probably the easiest.
So good news, Frank, we've got your Nspire screen at 1.2 open there in front of us.
Okay, excellent. All right, so with this bisection method, I want to find a rational approximation to this root. I know that it's going to be between A and B. F of A, F of B have opposite signs. So the bisection method works by halving the interval systematically. So if you go to geometry, constructions, perpendicular bisector. So I want the perpendicular bisector of A and B. And I now have this point here, which I'll call R1 for the first approximation to the root, which is the midpoint of A and B.
So Frank, sorry to interrupt there, apologies there. So it must be a bit of a lag time with where you are to what we're seeing now. We're just seeing the menu icons drop down, you're ready to go. So it might come through quicker, it might be a little bit slow, so probably just take your time there, so see how we go.
Okay. So I'll have to be very slow.
Yeah,
I'm not even relying on wireless. I'm actually on through Ethernet.
Oh.
Okay.
Maybe everybody's at home checking the emails and looking into
They must
at home.
be.
Okay. So yes, we're seeing you putting your perpendicular there. Yes.
Okay. So have we got the midpoint now?
You got the midpoint between A and B, that's correct?
Okay. Then I need to halve again, but I've got to decide, do I need to halve between A and R1 or between R1 and B? Well, what I need to do is to compare F of A and F of R1 with F of B and F of R1. Obviously, there's a change in sign between this point and this point, so I know that the interval must be, the root must be in that interval there. And note that it doesn't that the next iteration is not necessarily a better approximation than the one before. So it's a very slow iterative process. Okay, so we got the second one.
Yeah, she's getting that now.
Okay, so I've got R2. Now I have that, so I then have to decide which do I use as my endpoints. Do I use R2, F of R2 and F of A, or F of R2 and F of R1? Obviously there's a change of sign between this one and that one, so I have that interval again. And I just keep repeating that until I'm very close. Okay, so can you see that now?
Yes, we are. So you've just got that one just going closer and closer to it.
Yep. Okay. So that illustrates how bisection works. So you keep halving the interval until you are close enough to the accuracy that you want. Now, the good thing about this process is that it's very robust. It always works, but it's slow. It's slow, but it gets there in the end. And that's my understanding that TI-Nspire, when it tries to find a numerical root, it uses a combination of both Newton's method and the bisection method. Okay. Now, the next thing I wanted to look at was this activity called splining a pathway investigation. Now this comes from the advice for teachers. Now as I said earlier, if you go to the VCEA website or you just Google VCEA advice for teachers, the Maths Methods advice for teachers will come up. One of the activities is called splining a pathway. This activity is based on an earlier activity from, in fact, 1996, which was called Cycling Along the Yarra. And in this activity, you have, what you're trying to do is find a path that models a bicycle path along the Yarra River. All right. Now, can we see page 1.2?
Not yet. We're still on 1.1. So,
okay. So, in this activity, I'm going to try and show how to create this interactively. I was actually going to show from scratch, but I don't think I'm going to be able to be, obviously the connection is just far too slow.
We're on 1.2 now.
Okay. Now, what I've done is created a parabola that passes through the points 1, 4, 2, 2, which are fixed, and then this point, which is 4K. So the idea is that by creating an interactive page, you can grab the point C and vary the value of K. Okay, now I'm not sure whether that's coming up.
Yes, it's moving. Yes, yes.
All right. So how do you create something like this? Well, I think Bozenna showed the key. The key is to have a notes page. So in a notes page, you create a math box. Now, how do you create a math box in a notes page? Well, you can go Menu and Insert Math Page, or even easier, Control M. Now, the beauty of a math box in a notes page is that it's interactive. If you do a computation in a calculator page, then that's static. Once you've obtained the answer, it stays in history. You can't edit that. Whereas in the math page, it's interactive. So what I've done is I've substituted for the equation of the parabola, so it's ax squared plus bx plus c. I've substituted the values of x and y. So I've got 1, 4, 2, 2, and 4k. And then I've linked, using the same techniques that Bozenna was showing earlier, I've linked this value to k. Now, how do you link a value to k? You just hover over it and then hit Control Menu and link and just store it as k. All right, so if I wanted to link this one to a particular value, Control Menu, Store. As soon as you hit Store, it allows you to put in the value of the parameter that I wanted. In the previous one, it was k. And that allows you to create a dynamic page. Now, having solved that, I've got values for A, B, and C. I then substitute those values A, B, and C. I store those as some variable P. I substitute those into ax squared plus bx plus c, define it for F1, so F1 has got ax squared plus bx plus c with the value of that variable p. And by making it dynamic, you can vary that. Okay, just another minute, I'll show. I was going to show you how to do it, but it would probably take all day. Can you see 3.2?
Not at the moment, so we're just on 1.3. Oh, there we go. We're back to 2.1 at the moment. 3.1, there you go.
Okay, so in this, the next part of the investigation, we're also adding a slider where we've got the parabola, and then we are comparing the goodness of fit, if you like, of the parabola and a cubic. So with the cubic, the use of a slider allows you to change the value of D. And of course you can still just grab the point C and move that around. And one of the questions is, for what values of D do you get the best fit with both the parabola and the cubic? All right, and I think my time's just about up for this segment, so I'll pass back to Bozenna. Thank you.
Thank you, Frank. Under difficult circumstances there, so hopefully by the time your second part comes around, people off the internet in your local area, and Bozenna, you're about to be shared with your screen very shortly. So as we go there. There we go, your screen's being shown now.
The next little investigation, as it says in the advice for teachers again, investigations, problem solving, explorations, all those things are really using technology advised. So, not this one. So this is the investigative task, which the idea here is that we graph each of the cubics first and we observe what happens. Then we graph the cubics with some repeated roots, and again we'll observe what happens when the power is even and odd. We try some other graphs again and look what's happening when we get points of inflection, when we get actually touching or crossing. And at the same time, we can factorize and compare the factorized and unfactorized equation. And then we would ask the students actually to come with the general discussion, what happens to the factorized cubic with repeated roots for n even and n is odd. So the TI-Nspire, of course, is very useful here. So that is one of the screens, and they can clearly see that when we have an even power, the graph is touching. So if we press Ctrl-T, the table appears, and by scrolling up and down, they, of course, can also see the zeros in the table, and Ctrl-T removes the table. We can add that's another graph where we have points of inflection showing, and then we look at the other ones, and if you want to split the screen so they can see the unfactorized equation, the factorized equation, and the graph at the same time to make the final conclusion, what's happening when that's squared and that's not, and to get this layout, we go to page layout, and then you can select a layout. So you can have either vertical or horizontal split for the students to have more things on one screen, which is very useful for this particular investigation. And then they continue trying to do something by hand, and we talk about the point of inflection, and then they try to summarize what they've learned. To finish that off, you can, if you have a navigator, you can actually create some questions. So if you go here, you have question, and there is the choice. You can have true, false, yes, no, multiple choice. It's more really fantastic things there if you play with that, with images and points and so on. So I've created the one, and this one is simply asking, has no points of inflection, and they say true and false, and they can send it back with the answer, and then you have the option to analyze all the students and see what they've answered. Then another poll question, and you can come up with your own. So this is another true and false, and then you can have one of the multiple choice questions. And as I'm saying, if you send this short poll, you have it interactive with the students, and it works really well. So this is the task on polynomials roots investigation. The last one I would like to show today is exploring inverse functions. So the handout, which will be available, actually takes you through all the steps how to create the inverse function graph. Graphically in the graph screen, as we know, the TI-Nspire still doesn't have this functionality to draw an inverse graph, but it's not a very complicated construction. But once you have the construction, then of course you can send it to the students if you have even a docking station, and they can play with that. So there is a nice discussion why we need to have one-to-one function for the inverse function, and they can see it graphically. And then of course if we go to the file, and that's part of the construction, and then once we have those graphs going, so all you do, you simply change your F1. So I started with x cubed, and then I got a graph, but we might get x plus 2, and then we'll get of course 2 straight lines. And so students can just look at different graphs, and I go back to x cubed, and then they might, what did I do, the other graph doesn't matter, I'll go to the next screen. So that's the one where they've entered the cubic and showing that the inverse is not. They can also drag the point and see what happens with another point. So that is showing how one point is actually reflected in the line y equals x. And that's another construction. If f1 is x cubed minus 5, then that's the inverse graph, which they can do by hand and then check by entering the function whether this is actually the red line being shown. So that's asking them to show it algebraically and then actually enter the equation, and it should go red over black line in the construction. And then I've got these challenging questions: which linear functions are their own inverses? So like in year 11, we only really look at simple quadratics with the restricted domain and straight lines. We can do inverse of the hyperbola as well, and they can try it graphically and think about it. And then again, I have a few poll questions, so true and false, and then if we restrict the domain to this particular one, that's a bit harder one. Point on the graph, when drawn on the graph, will have the coordinates, so it's a little bit more of a thinking question. Find the inverse given that. So students type response, and then you can collect those responses and look at what they've done. So that is this investigation, and you can either actually construct that or just send them the file and let them play with the file for the inverse graph. So back to Frank. Thank you very much for your attention tonight.
Thank you, Bozenna. So as Bozenna shown there, that using the navigator and creating questions by inserting questions as coordinates or multi-choice, very easy to check for student progress, and as teachers that's essential in our classrooms. So as we're waiting for Frank and his screen, so hopefully the internet connection is a little bit quicker here, Frank. So we're still waiting for your screen. And see how we go.
All right, well, while we're waiting for the screen to come up, by the way, if you want to let the politicians know that we need the MBN in the country as well, please feel free to do so. In the meantime, I guess something I would like to say is that it seems to me that in the new study design, when it comes to the school-assessed coursework, there is certainly a renewed focus on investigation, modelling and problem-solving. And, you know, what better tool to support those approaches than TI-Nspire, where you can create the sort of interactive sheets that Bozenna and I are showing, and you can really do serious exploration of an idea. You can do modelling, problem solving, and students can easily ask, what if?
So, Frank, okay. Yeah, so we've got your screen, so we've still got at least 15 minutes of our time, so you've got a bit of time up your sleeve to show a few things and some construction.
Okay, so I'm going back to Bisection, this time showing I showed the graphical approach, now a spreadsheet approach, but as you can probably tell, I'm a big fan of math boxes in notes pages. So in this, by the way, all of these files will be available for participants after the webinar. So I can enter a function. I'll enter one where we know what the root is, so 3 minus x squared. And because you have to hit enter to execute, and the endpoint, so I'll start with 1 and 3. So I know that my root is going to be between 1 and 3. Now, on the next page,
which is still coming.
Okay.
Low again.
So on the next page, we've got, I've set up a spreadsheet, and I'll include all the instructions for creating this spreadsheet and the rationale for the formulas in the spreadsheet, but it's very, very easy. Okay, do we see the spreadsheet? Yes?
Yes, the spreadsheet's on there now.
Okay, so in this cell, I start with my starting value, A, B, and if I change those on the other page, it'll change them in the spreadsheet. Since that's the reason for using the notes page rather than a calculator page. So here, I calculate my approximation to the root, which is just the midpoint of A1 and B1. And over here, I calculate f of R1. All right. Now, what I then, having found the midpoint of my interval in this cell, I then have to decide, well, what do I use as my next interval? So I ask myself, if I use, that's where I use the if function. So the formula is if the sine of D1, where D1 is f of R1, is the same as the sine of F1, then I have to use C1, C1 being R1. I know it's a bit confusing. It all makes sense if you look at the formulas. Otherwise, I use A1. So all I'm doing is comparing the signs. Are the signs the same or different? And I do the same here. Are the signs of the same or are the signs different? So where the signs are different, that's what I want to use as my endpoints. And having decided which I need to use, I then find that interval, that midpoint, the midpoint of that new interval, and f of my next approximation. Now, because I've used relative cell references throughout, I haven't used any absolute cell references, they're all relative, I can now select all of those. Now, if you, to multiple select on your handheld, hold down the Shift key and press either left, right, up, down, whichever direction you want to go in. So you go across that way. Now, the best way to fill down, there's a whole lot of different ways of filling down. My preferred way is having multiple selected, I then do Control click. So Control click and then just down arrow. Enter. All right, and all the formulas have been updated. So where I had where I had the midpoint of A2 and B2, it's now A3 and B3 and so on. And what you're looking for, this column here, the third column, is the approximation to the root. Now I'll just do a few more iterations. That's 4 iterations. Let's do some more. So once again, multiple select, Control click, down arrow.
I'm still doing it. It's very powerful as you're doing that, Frank, isn't it? So we're so used to being on the computer with the keyboard, and so on the handheld, it's very important they use the Shift and then your arrow key switch direction, And then
Absolutely.
Control-click to grab it.
Absolutely.
Very powerful.
Now, by the way, the shift and left, right, and whatever, that works on any keyboard in any program. That's not just TI-Nspire. That will work on Microsoft Word, for example, or whatever. Okay, and you can see here now I've done 14 iterations, and we can see that Rn is getting closer and closer to the value that we know to be the square root of 3, 1.73. I mean, I'm not Rain Man, so I don't know root 3 to too many decimal places. But the other column to note is this last column. We would expect that as we get closer and closer to the root, that f of Rn, where Rn is the nth iteration of the approximate root, that f of Rn would be getting close to 0, and we see that it is. And let's just do a few more. Okay, and Control-click, down arrow, and we see that now we're getting to really, really small values, so very, very close to the square root of 3 and very close to 0. So it's a very robust method, but a very slow method. And it's really good for students to understand how technology works out these numerical computations. And I think there's a lot of value in students actually creating this spreadsheet. I reckon that by creating the spreadsheet, they are likely to get a better understanding of the method.
I totally agree, Frank.
Yeah. Okay. So the next one I wanted to have a look at is one called drug dosages. Now, these are medicinal drug dosages, by the way. Now, this is based on a 1995 investigative project. Now, I think if you want to get ideas for what's a really good application task, if you're in an older school, go back to the storeroom and look for old investigative projects. These were mandated by what was at the time the Board of Studies, which became the VCEE. And in this particular one, the idea is to look at a function for the concentration of a medicinal drug in the bloodstream, and the function is of the form a to the power of t to the power of b times e to the negative t over k, where t is the time since administering the drug, and the others are parameters. All right. Now,
we're still seeing a slideshow at the moment on the Nspire. Oh, there we go. We're seeing your screen now. Let people have a read what you're about to do, Frank.
Okay. Well, I'll actually
probably click, and then we probably have time to read it. They'll get onto it. Yeah, we're seeing page 1.2. That was quick, Frank.
Okay. So I was going to show how to construct.
We can do that, Frank. We've still got some time up our sleeves.
Yeah, but the trouble is whether I can do it. It's a matter of whether
the internet
can actually see it. Okay, so I'm actually on. I've skipped ahead to 3.1. So we're on 3.1, yes?
Yeah, it's slowly coming through, so we can just see your. There we are, 3.1, Frank. Yes.
And 3.2.
So as you see, Frank, you like your math boxes. They're very powerful, aren't they?
Okay. And in particular, with the math boxes in 3.1, I've actually linked those math boxes to two values which I've called x1 and y1, which are actually the maximum values of C, so that's maximum concentration. So that's what I've done in 3.1. Because this is going to allow me to have the maximum concentration showing up dynamically as I use a slider to change the value of the parameters. All right, so we're on 3.2, yes?
We are, yes, watching you describe as you speak. The two sliders are there.
All right, so I can first of all change the value of k. So change the value of k. Now, in the red graph has a equal to 1, and in the other one it's a equal to 2. And you can see the value of the maximum also change. And actually I'll adjust this to 1. And this is what the previous one was supposed to show, problem 2. I was going to create it from scratch, but I'm not sure whether by the time I finish creating it, the session would already be over. So the interesting thing is that as students change the value of k, they see that the maximum occurs, the time for the maximum concentration to be reached is the same as the value of k. All right, so when I have k as 11, then it takes 11 minutes for the maximum concentration to be reached. What does the parameter a do? You can see the parameter a changes the amplitude. Okay, so all I've done there, I've got the sliders, and how do you create sliders? Menu, actions, insert slider. It's very, very intuitive. How did I make sure that the maximum stayed interactive? I did that in a text box in a notes page. And all of these will be available for you to have a look at. And I think we're ready for wind up, so I'll pass back to you, Rodney. And thank you very much for listening.
Thank you, Frank. You've done extremely well with trying circumstances with your connection there. So as you said, you'll see that the files that we will receive from the webinar will be online shortly in the next few days. So I'm about to share my desktop shortly here. So in summing up, I'm thanking Bozenna and Frank, and in my usual summing up of the webinar, even up here, it's like this, up here is very slow as well, we're getting there. I'm actually going to visit the Texas Instruments Australia website, and I'll show you shortly, and it's coming soon. And yeah, you're not seeing my screen, are you, Frank?
Not yet.
Not just yet.
Oh, here we go. I'm sharing my screen now. So, as I said in summing up here, so with the if you're looking for the Australian website, you're not sure, so it's education.ti.com, and you'll see the link there. Often I just type AUS and Australia there, and it'll go to that website. So, and you'll see in the middle of the website, you'll see that the webinars icon there, which I've just clicked on, you will actually visit the webinars and the upcoming webinars that we've come. So you've seen there that we've had those webinars that are there, and tonight's webinar was Frank and Bozenna, and Thursday we've actually got Roger and Brian. So for any participants there who'd like to register, so do that. So always look to the website for those upcoming webinars. And of course, if you click the On-Demand tab, you'll see that the previous recordings and any associated documents that Frank and Bozenna are going to share with you, they'll be there. You can download. play the webinar online, or you can download the webinar and play offline. You record your external hard drive. So at the conclusion of this webinar, as I said at the introduction, you'll see a survey to complete. Please complete and provide feedback to Texas Instruments Australia and the participants and the presenters. And then also you'll receive your follow-up email within a couple of days. We'll have your certificate link. And take care. We look forward to your participation in future webinars. Thank you, Bozenna.
Thank you.
Thank you, Frank.
Thank you, Rodney.
You've done well for the trying circumstances there. And good evening until next time. Bye for now.